So yeah, welcome back. Today we are going to solve this problem, jump game 3. So let's hop into the description about the question. So yeah, given an array of non-negative integers ARR. Okay, so first observation is that it contains non-negative numbers. Second is you are initially positioned at a start position index of the array. Initially at 0 index. When you are at index I, you can jump to I plus array of I or I minus array of I. Okay. Check if you can reach any index with value 0. Check if you can reach any index with value 0. Notice that you cannot jump outside of the array at any time. So, um, yeah, this is something different from all the rest of the jump game which we did. So here we need to find the path which can result us to 0. So I think we are starting from here, like index 0, and we need to reach till index 3. So one way is to, like, I can go I plus array of I, which will make it me go to this value, which is index 5. I can go to I can go to for 5 minus 3. Okay, this is 0th index, but why they have stated here index 5, I am not pretty sure. So let's see, like, I can go to index this thing, right? This is index 4, I think. 0, 1, 2, 3, 4. I don't know why they have stated here index 5, to be frank. And okay, we have been given start index. Okay, sorry, my bad. So we need to start from this index 5, 5, and I can go to index 4 and index 6. Index 4, if I went, I can go to index 1, which is I minus array of I. 4 minus 1 is 1. Yeah, index 1 we went. And index 1 we can go to index 3. So let's see the constraint. It is 5 into 10 raised to power 4. So I think we can go with of n square also is possible here. That should not cause any issue for us. Or what we can do, like, we are not pretty sure, like, is this greedy or not. So I'm thinking more of like this is greedy or not. But my mind is saying that we can go for O of n square, that on the basis of the constraint we are pretty sure that this might be uh, like recursive or something backtracking. But I want to still give it a shot with greedy. So if I, like, have, like, I start with index 1 here. So if I go to 2 part, might be I can directly reach from here to here. So I'm not pretty sure, like, if I should perform this operation or this operation. I'm very much confused in a greedy approach, that which operation will lead to the answer, and there is uncertainty with each of them. If I perform, like, only uh, let's say if I go from here to here, and what if it is 7, then it might end up like throwing us out of the array. And what if it is like we only take right part, and what if it is 10? It will also end up us throwing out of the array. So I think there is a lot of uncertainty between which one to choose. So I think, yeah, it will be better if we can go with the backtracking solution. So yeah, let's start with backtracking one only directly. So yeah, so what was our thought process? Let's write it down. So this is more of like my thought process and observation here. So now let's get started by coding. So let's have int n is equal to arr dot size, and we will have like start position which will be there. Okay, let's have traversal. Let's traverse. Let's pass arr starting index, the index which we are starting with, and let's pass in. Let's have a variable here. Bool is possible is equal to false. Since at the start it is not possible, let's return is possible. Okay. Now let's have like void traverse. So let's pass vector int ampersand arr int start position and int n. So this is what, like, if start is less than 0 or start is greater than 0, n greater than equal to n, we need to return simply. Like, this solution won't work out, like we reached some of the index which is not a valid index. Now if arr of start is equal to 0, that means this is a valid one. So we need to make is possible equal to true, and if we hit is possible true anytime, we can return here, like return from here basically. So now what should be the traverse? Traverse is equal to arr of I start plus arr of I. So either we can jump from this index, like uh, from this start position to plus I, like what was written here. Start is the I. So let's say if I'm at position I here, which is a start position, I can go to start plus arr of I, or either I can go to start minus arr of I. So yeah, that is what I'm writing here. So this is the one. Traverse arr comma start minus arr of I comma n. So I think this is cool. Let's try to run it once. Okay, we did got some thing. Okay, we need to add here start. And we need to have here start. Okay, I think we ended up getting into the okay. Okay, so we will need another map. So what is happening is like it's getting into the loop. Like let's say here one is there and here one is there. So I minus one will get me here one, and I plus one will again get me here one. So this is getting into the loop. So we need to mark all these indices as visited. So what I'm doing for that is I'm having a map, and in which I will be storing int value. Corresponding to that, I will be storing the bool value mp, which will basically help me to know like if that was visited or not. So let's mark it as true if mp dot find start position is equal to mp dot end return. So we will basically return like it was already visited. Why do we need to visit again? And if not, then mp of start is equal to if mp dot find start. Okay. not getting to this error. Okay, what is this error? I think, okay, we have marked it as. Okay, so yeah, we ended up getting the wrong answer here. I don't know why, but let's try to see like why did we get here wrong. So let's try to print here start so that we can get like what is happening here. Okay, so we are going to start 5. 5 is not here, and it's okay, it's only printing one value. I'm not pretty sure like why it's only printing one value. So let's try to see like where from where it is getting pumped out. I don't, that's not here, there is no return statement, so this will not cause this error. Also we are calling this function, right? Yeah, so I think this was the reason. Is this the reason? Okay, we did wrong here. Okay, yeah, this one looks pretty much accepted. Let's try to submit it. Okay, yeah, I think this got accepted. So yeah, basically I will try run it once more so that it will give us more clarity, and we will try to submit it again so that we can get like why it end up here. We moved some. Okay, so yeah, so what I thought was basically like that actually, yeah, we will try run this code. So this is traverse array start of n. So we took like arr as an input and start and n as the size of the irr, and is possible is something like if we end up like reaching here. So that is what we took here. If is possible, then we don't need to further proceed. Like we have already found that is 0 present. Why do we need to go make other calls, other recursive calls? So yeah, and if start is less than 0 or start is less than greater than equal to n, which means like we are like -1 position and starts end up like going to uh, more than the size of this ARR. So this will is not a valid index. So we just need to return here. And same like if array of start is equal to 0, then this is the what we needed before. So we will do is possible is equal to true. And if is visited dot find start is not equal to not visited at end, then we need to return. So what is happening here basically, like let's say if here it would have been 1. So what would have happened like this -1 would have got me here, and here also 1 is there, then this plus index plus 1 would have got me in here. So this would have gone in loop. So if we have already visited this index, and if we get from here -1, then this will get here and we will probably return like we have already visited this index, why do we need to again visit, right? So that is what this condition will take care of, and we will mark it if it is, if it has not been visited, we will mark it as visited. And similarly we will traverse like start plus array of start, like we are doing this operation I plus array of I, or we will do array of I minus array of I. So this is what this two recursive calls will take care of. Yeah, so yeah, that's all from my side. Thank you. I think you were able to understand the solution.